of fusion of ice, it is 33 kilojoule. Kilojoule means 33 times 10 raised to the power 3. You have to take note of that. They said 3 kilojoule. Kilo means 1000. That is 33 times 10 raised to the power 3 joule. This 10 to the power 3 is representing kilo. Okay? Kilojoule. Okay? So we are going to evaluate this. Let's see what will be the value of this. 2 times 2 is 4. Then what will be the value of 4 times 2090? 4 times 2090 will give us 8360. Plus, what will be the value of 2 times 1000? That's 2000. Because 10 to 3 is 1000. Okay? 2000 times 33. What is going to be the value? 2000 times 33 will give us, that is 66,000. 66,000. So if we add the two together, we are going to have 8360. Altogether, we give us 74360. 74360. Quantity of heat in what? Joule. In joule. 74360. Question number 5. The amount of heat needed to raise the temperature of 10 kg of copper by 1 Kelvin is its A. Specific heat capacity, B. Heat capacity, C. Specific latent heat, D. Internal heat. We are going to consider each of these one by one. What is specific heat capacity? As I have told you the other time, the amount of heat needed to raise temperature of a unit mass of a body by 1 degree Celsius. Let's take note of that. What about heat capacity? Is the amount of heat needed to raise the temperature of a body by 1 degree Celsius. But for specific heat capacity, it says a unit mass of a body. A unit mass. Let's underline that. The latent heat is the heat supply which breaks down molecular force of attraction rather than increase in kinetic energy of molecule, and then it's just the amount of heat we supply to a body to convert heat from the original form to another form, either from ice to water, or from vapor back to water, or from yes, that is latent heat. So what will now be the right answer to the question? The question says the amount of heat needed to raise the temperature of 10 kg of copper by 1 Kelvin. 10 kg of copper by 1 Kelvin is heat. The right answer is heat capacity. Heat capacity. According to all the as you have considered each of them one by one, the answer is heat capacity. Question number 6. The question number 6 says a tap supplies water at 25 degrees Celsius, while another supplies water at 75 degrees Celsius. If a man wishes to bath with water at 40 degrees Celsius, the ratio of the mass of cold water to the mass of hot water required is, we have different temperature here. Heat loss is equal to heat gain. We are going to have MC into, let's look at the question. A tap supplies water at 25 degrees Celsius, another supply water at 75 degrees Celsius. The one at 75 has higher temperature than that of 25, which is of lower temperature. Okay? So, if a man wishes to bath with water at 45 degrees Celsius, what will happen? By the time they mix the water together, we are going to have the one with higher temperature, which is T2 minus T1 will be equal to MC theta T3 minus T2, which is equal to, what is the mass of the water? We are given, okay, we are told to calculate the ratio of the mass of cold water to that of hot water. Okay, this is cold water that gains the heat. This is hot water that loses the heat. Okay, so we are going to have the mass is what we are looking for. Okay, are we given the specific heat capacity? No. So this cancels this. Then we are going to have the temperature, which is 75 minus, then we have 25 will be equal to 33, which is 40 minus 25. So what I'm going to have now, 75 minus 25, we are going to have 20 plus 70, that's 50, that's 45, will be equal to, what we are going to have here, 20 plus 44, that's 20, that's 15. The ratio of their mass will be equal to, we are going to have, this is the one that is losing heat, and that lose heat, which is the one for hot, this is cold. We want to find the ratio of the mass of cold to hot. So we are going to have 45, 15, this divided by this, so that will be equal to mass of cold, mass of hot. Okay? If you try to break this one down, this is 5 in 45 is 9, this is 10. That is 9 divided by 3 will be equal to mass of cold to that of mass of hot. You can see, because this can be 3 ratio 1 will be equal to mass of cold ratio mass of hot. So in ratio is 3 ratio 1. We are going to consider a new topic, and the topic is change of states. Under this topic, the candidate should be able to differentiate between latent heat and specific latent heat of fusion and vaporization. At the same time, the candidate should be able to differentiate between melting, evaporation, and boiling. Candidates should be able to examine the effects of prior and of dissolved substance on boiling and melting points. And at the same time, finally, the candidate should be able to solve some numerical problems. We are going to consider briefly what this topic is all about. The change of state is said to occur if a body is converted from its original form to another form due to gain or loss of latent heat. that is change of state. If we try to expatiate further, you know we have the three states of matter, which is liquid, solid, and gas. So the change of state we are talking about, that it is possible for a liquid to change to solid, and it is also possible for a solid to change back to liquid, change of state. It is possible for a liquid to change to gas, and gas can also go back and change back to what? Liquid. That is the change of state. Example is ice block. If you try to boil water now at a particular temperature, before you know it, it will change to vapor. That is the change of state we are talking about. And all these changes are taking place at a particular temperature of the other. Let's consider the word latent heat. Latent heat is what we also call hidden heat. Heat supply which breaks down molecular force of attraction rather than increase in kinetic energy of molecule. So therefore, latent heat cannot be measured by thermometer. Let's quickly consider what we call specific latent heat. This is the amount of heat